This is a question from IPMAT Indore paper QA section 2024, and the question is based on percentages and simple equations. A fruit seller had a certain number of apples, bananas, and oranges. So there are three types of fruits involved. At the start of the day, the number of bananas was 10 more than the number of apples, and the total number of bananas and apples was a multiple of 11. So bananas and apples, the total number is a multiple of 11. This point is important. And this next point is very important. She was able to sell 70% of apples and 60% of bananas. Now, because the question involves selling apples, bananas, oranges, that means these fruits are sold in whole numbers. So whatever numbers are there, all of them have to be in whole numbers, right? So initial number obviously should be whole number. When she is able to sell 70% of the apples and 60% of bananas, so the number of apples and bananas that were sold or that remained, they should also be whole numbers, because bananas or apples, they are not normally sold in fractions or in parts, right? So all the numbers involved in this question, they should be whole numbers. So that is where our assumption come from. So 70% of apples, if I assume the apples to be x, so I can say the initial number of apples, let us say x, right? So she was able to sell 70% of them. So she sold how much? 70% of x. So 7 by 10 times x, right? So what does this mean? It means because this number has to be a whole number, x has to be a multiple of 10. The number of apples has to be a multiple of 10. Fine. The number of apples, this x, must be a multiple of 10. Number of apples must be a multiple of 10. Next point is, question says that the number of bananas was 10 more than the number of apples. So if number of bananas is 10 more and the number of apples is already a multiple of 10, the number of bananas should also be a multiple of 10, right? So we will reassume number of apples. Instead of x, I will assume 10x. Number of bananas, this is the initial number. That should be 10y. So total of this will be 10 times x plus y. So the total of number of apples and bananas should be a multiple of 10. And question says that this is also a multiple of 11. The total number of apples and bananas that was initially there, it should also be a multiple of 11. So a number is a multiple of 10 as well as of 11. That means it should be a multiple of their LCM. That means 110, right? So the total number of apples and bananas would be a multiple of 110, which is the LCM of 11 and 10, right? So the total number should be 110 or 220 or 330 or 440 and so on. So total number can be 110 or 220 or 330 and so on. This is the total number of apples and bananas only. I think the explanation is clear till this point. Now we have to take which one should be the number. So the question is, if she was able to sell 55% of the fruits she had at the start of the day, then the minimum number of oranges, right? Then the minimum number of oranges she had at the start of the day was. Now because we have to minimize the number of oranges, we have to minimize the number of apples and bananas also, because she has to always sell 55% of the total fruits. If the number of bananas and oranges is more than 110, that means 220 or 330. So 55% of that will be proportionately higher. That means the number of oranges should also be higher. right? If we want to minimize the number of oranges, we should go with the minimum possible number of apples plus bananas. That means we will go with 110 only, right? So there is a lot of logic behind why did we only decide with 110 and not any other number, right? So total number of apples and bananas can be taken as total number of apples and bananas is 110. This is the initial number. Fine. Out of this, I can say number of apples and number of bananas will be 50 and 60 according to the given conditions, because number of bananas was 10 more than number of apples. So you can simply write this equation. Number of bananas agar aap x lete number of apples, so this will be x plus 10 and their sum will be 110. So this is the reverse process that we have done. So by solving this, we will get this 50 and this is 60. Right? So we know the number of apples and number of bananas. We'll go back to our question. Out of this number 50 and 60, she was able to sell 70% apples and 60% bananas. So what is the number sold? What is the number sold? For apples, she was able to sell 70%, that means 35. From bananas, she was able to sell 60%, that means 36. So 35 plus 36, 71 fruits she has sold out of total 10. Fine. Now the question is, what is the minimum number of oranges so that she is able to sell 55% of all the fruits? And she sold 50% of oranges. So I will assume the number of oranges. So if I assume, let the initial number of oranges be 2a. We have already assumed x, taken x many times. Let us say 2p, right? So 2p is the initial number of oranges. She sold 50% of the initial number of oranges. So she sold p oranges. Right? So what is the total number of fruits sold? 71 apple plus bananas and p oranges. So 71 plus p. This is the total number of fruits sold. What was the total number of fruits she had plus bananas and 2p oranges? So 110 plus 2p. This is the total number of fruits she initially had in the beginning. So the number of fruits sold is 55% of the total number of fruits she initially had. Right? So this will be the equation that can be solved to get the value of p. So we can solve this now. We can first cancel them. 11 and 20. So 20 into 71, 0 to 1420 plus 20p. That should be 1210 plus 22p. This goes there and this goes there. Right? So what do we have? 2p. 2p was the initial number that we have assumed. So 2p will be equal to this much. So 1420 and 1210 is 210. So 2p is 210. We don't have to divide because 2p was the initial number of oranges that we had assumed. So 2p का value directly आ गया 210 and that should be our answer. So answer is A 210.